the entire course and really beyond this course into other areas, sometimes we're going to be interested and say, okay, this is what happens in some maybe real life phenomenon when we're talking about x values that look like this. But when x values are maybe a little bit differently, this is how something behaves. Okay, so that's what we're talking about. What is the behavior of these curves for different x values? Okay, so the first one we see here is two very simple rules. One rule is negative x under the condition that x is less than 0. Okay, so we're going to graph negative x only on the xy plane when x is less than 0. Okay, then we've got the rule that we're going to graph x when x is greater than or equal to 0. Okay, so kind of walk you through the way that you would do these by hand. Okay, the one issue that we have with WebAssign is that we don't have like it doesn't have them creating like a two-dimensional plane for you to drag points and lines and make these things like we're graphing them by hand. So there will be a situation maybe where we have some worksheets that I'm going to provide for you so that you guys can get a good idea of how to go about the structure and creation of these. Your assignment right now in WebAssign basically gives you one of these, and it gives you 4 or 5 graphs that you have to choose the right one for. Okay, so I think that's a little bit easier than what graphing these would be. Okay, a lot of times we're going to be asked to graph them later on in other areas, maybe in a calculus course or something like that. We need to be able to do this. All right, so here's the idea. These points here, okay, these domain values, these cutoff values, they're telling you what values to choose for that rule. Okay, so even though I've got the value of 0 and x has got to be less than 0, so we're talking about like negative 0.0000000001, right? I don't want to have to plug that number in, and I don't want to do the math with that because that number, even though it is to the left of 0, it's not the first number to the left of 0. Okay, so we're talking about the idea of plugging in negative 0.00, an infinite number of zeros and a 1, right? Well, that's not feasible for us to do, so we don't do that algebraically. We do that with 0 instead. We plug in 0, okay? And we plug in 0 and evaluate the rule negative x for 0, okay? So if I plug in 0, what do I get for negative x? I get 0, right? Okay. However, was I really allowed to use 0 there? No. Even though I plug it in here, I use it and I plug it in, I get 0 back. So I got the point 0, 0. What should I put there though when I do the point 0, 0? Should it be a closed dot? No, it should be an open dot, right? Okay. So we'll make this an open dot. And that just shows me, it tells me that for this rule so far, this number here is not existing. Okay, we're not at 0, 0, but I'm right next to it. Does that make sense? Okay, and I'm not at a y value of 0, but I'm right above it. Okay, so that's the idea of that open dot. So now we got to try, this is what kind of shape, what kind of function is this, or graph would I get from negative x? Is it linear or non-linear? It's linear, right? It's going to give me a line. So how many points do I need to determine a line?
2.
2. I just need 2. Okay, so I've got 1. Now I just need another input value, another value smaller than 0. So maybe I choose negative 1. Okay? So if I take negative 1 as my x value and I plug it into my function, okay, we get 1 comma, or negative 1 comma, evaluate it in my function. You see how it splits back that point b, right? Okay? Because when the function evaluates negative 1, it knows that negative 1 is in this domain. It's in this x is less than 0 stuff. So it's going to plug negative 1 in here, and you see that gives you back positive 1. Does that make sense? Okay. Can I do the same thing with like negative 2? Plug in negative 2, it's in this domain, so I plug it in this rule. The opposite of negative 2 would be positive 2. Okay. So we got a couple points here, negative 3, 3 is going to do the same thing. Is that enough stuff though? Even if I just got that second point B, is that enough for me to take my straight edge? and connect them and create that line? Okay. So now the next one says, okay, we've done all of these. We've done all of those points. Let's look at this rule now here. Okay, we got this restriction. Okay, we're going to use those x values, and I plug them into this rule. Okay, so the first x value that I'm going to choose is indeed 0 in this case, right? If I take f of 0, okay, so take x value to be 0, and I'm going to plot that with f evaluated as 0. So this part here is going to give me my y value, okay, when I plug 0 in. Okay, well it says plug 0 in right here, right? What's that going to give me? I plug 0 into this, it gives me 0, right? I get the point 0, 0 again. Okay, but now if it's equality, what happens to that point 0, 0?
Actually works.
It closes it up. Okay, so I no longer have an open dot there. All right, an open dot and a closed dot can overlap each other because the open dot notation actually means there's not a point there, right? Okay, so we just kind of filled in a gap there. Okay, that would have existed in our line or our curve if we did not have equality. So now I'm going to choose numbers that are bigger than 0. So maybe I choose 1. If I take 1 and plug it in this rule, what y value do I get back? 1. If I plug 2 in, what do I get back? 2, right? So I get the point 1, 1, 2, 2, 3, 3. Okay, how many of those do I need to make a line? Yeah, just those 2, or any of those 2. Okay, and we get that image when we graph this thing. And that's a function, pass the vertical line test, right? What do you know that to be defined as, or better to be defined as? That's the absolute value function, okay? The absolute value function that you guys are familiar with, a linear absolute value function, is simply defined by a piecewise, which says when you choose a negative value, you take the opposite sign of it, okay? And that's what that first rule up there is doing, okay? When you have a positive value, you leave it alone, okay? So that's the absolute value function there, but we can see it described or defined as a piecewise. Okay, that's usually the first one in any piecewise instruction, regardless of who your teacher is. That's probably one of the first ones that you're going to see. Okay. All right, so let's do another one. Let's do this one here. All right, so we've got the function f of x equals 3 if x is less than 2, and we got the rule x minus 1 if x is greater than or equal to 2. Okay. A lot of these early on, I've got the domain set up to where it's continuous. Okay. If I think about those two domains, x is less than 2, because that's a domain for the rule 3, right? The x values are going to provide that output of 3. My domain for x minus 1 is x is greater than or equal to. If I put those two domains together, are there any numbers on the number line that are left out? Think about the numbers that are less than 2 and the numbers that are greater than or equal to. Nothing's left out, right? So here you start to see maybe some examples where the restrictions together as a union provides me the entire number line. That doesn't have to be the case, it's just what happens sometimes. Okay? I could have said x is less than 2 and then made x minus 1 for x is greater than 5. So I skipped some values. Okay? But if x is equal to 2, okay, x is equal to 2 for this top one, because so I'm going to use that value. Even though it says inequality, to evaluate, I'm still going to use that number. So if I evaluate at 2, what's the y value I get back? 3, right? Okay, so this is really saying the line y equals 3. Okay? So when x is 2, the y value I get back is 3. So I'll plot that point. But now because it was less than, what's unique about that point? Should be open. Okay? And there we go. Alright, so open up. Now if I try a number less than 2, okay? Choose any value less than 2, the y value you get back should be 3, right? Okay, So if I choose, 0, 0 is less than 2, y value I get back should be 3, correct? Now that should be a closed dot. Struggling. Alright. How many points do I need to graph the line y equals 3?
2.
Just 2. Okay, now the ones that you use might have been different than the ones that I used, but we should both get that portion of that line. Okay? Now we jump down, we've got that graph, okay? So now we jump down to this rule. So when x is greater than or equal to 2, we go x minus 1. Well, the first one we're going to plot then is x equals 2. If x is 2, what do I get back here? I get 1, right? So 2 comma 1 needs to be plotted. Now, is that an open dot or a closed dot? It's closed. Okay, because we had equality, right? Now, this is again a line, right? So how many other points do I need to graph a line? Just need one more. So what x value you want to choose? 3, that's fine. So I plug 3 in, what do I get? I get 2 back, right? I plug 4 in, I get 3 back, right? Any of those will work. So 3 comma 2, is that enough to make that line right there? Okay. Now if you're doing this by hand, my suggestion, do a couple more points. Do like 4 comma 3. Okay. Especially if your points are really close together. Okay. Creation of more of those, to make sure that I've got that precise line. Now, usually speaking, though, when we're done, I just want to look at point A and C, and I want to hide the other ones. The other ones were there to help us create what we've got, right? That is our piecewise function. Is it a function? Absolutely. And it's a function because if I plug in x equals some value here, make it r, here's my vertical line test, right? And I'm only intersecting right now one time, and really the only issue I get here is right there, correct? Okay? But at A up there, I'm not touching that vertical line, right? That thing is getting right up to it, okay? But it's not touching. But it is touching it down to C, correct? So we've only got one value evaluated at 2. So it passes the vertical line test there, and then obviously it passes everywhere else. Okay, so this is still a function. That's why they're called piecewise functions. Okay, because they will then indeed pass the vertical line test. All right, so let's do another example. Let's see this one. It's kind of you guys can see when I click on this is how you have to type them in GeoGebra. You type them in as basically if-then statements. Okay, so if my x values are these x values, so if x values are less than -2, then you plot the y value of 4. Does that kind of make sense? And you can start to see the other rules would be written that way as well. Okay, so they're if-then or conditional statements that we talked about in geometry. So I read this, the first one, like I said, is that if x is less than -2, then the y value is 4. That middle one says if x is between -2 and +2 inclusive, then your y value is x squared. Okay, or you evaluate those x's at x squared. And then that last one, if x is greater than 2, then you evaluate at -x+6 to get your y value. Okay, so this one is a 3-piece piecewise, and you can have as many pieces as you want. Okay, the idea usually us doing maybe 2 or 3 at a time, maybe 4 or 5 sometimes in WebAssign because they're already graphing for you. You just have to pick the graph, but you can do as many as you want. Okay, we'll see one maybe Monday that is, maybe we can write it as an infinite number of pieces. Okay, they all have kind of a pattern to them. So, first one we're going to do, x is less than -2. So I'm going to evaluate at -2, right? Choose -2, and what would I get back if I choose -2? I get 4 back. Okay, so negative 2, 4 needs to be described on my line or my graph, but what kind of point is it? It's open. And that tells me that negative 2 really isn't a value that I'm choosing. Negative 2.00000000001 is a value that I'm choosing, but not negative 2. Okay? A number further to the left of negative 2 or more negative than negative 2 would be like negative 4, right? If I choose negative 4, what y value do I get back? 4. Okay? So, even if the nice thing about GeoGebra now, evaluating at these points might not be great, okay? But evaluating somewhere within this interval, so if I evaluate at f of negative 4, GeoGebra is going to take that negative 4 and it's going to compare it to that, and to that, and realize, oh, it should be in this interval, so we'll put it in here, then that's the rule I should get back. So when I hit enter, I should get 4 back. Oh, it's P instead of F, sorry. So plug that negative 4 in, and I do get my 4 back. Okay? So negative 4, comma 4 needs to be on our curve. Okay? Is that enough to make that image, the line y equals 4? Yeah. So that's what we got. Alright? So the next thing we're going to do is, okay, we get down to this interval, negative 2 to positive 2, and we're including both those. So I need to evaluate at negative 2. If I evaluate at negative 2, what do I get back here? 4. Okay? So if I try f of negative 2, GeoGebra is going to find where that should go. It should go in here. You see that it's P, isn't it? It's going to know when I plug negative 2 in that it should go into this rule. So it's going to evaluate at x squared and it gives me 4 back, right? So I need to point negative 2, 4. Okay, but that was already there, right? It was open though. So it means it really wasn't there, correct? Now I've closed that off. Okay, so an open dot and closed dot, by all means, can overlap each other. Okay, it just closes that portion of the graph up. Okay? Now, this is where we gotta be careful. In that x squared, okay, is that linear or non-linear? Does it give me a line or not a line? Not a line, right? It gives me a parabola, right? Will 2 points define a parabola? No. So we get in the habit, a lot of times we see we got a lot of lines, we graph a lot of lines. And then we get something that's non-linear, like x squared or square root of x or x to the cube or something like that. And we use the idea that, oh, we just got to try negative 2 and 2. Well, that's only going to give you 2 points on that curve, and it's not going to be enough to graph the curve. Okay? So you got to pay attention to whether the rules that you're getting are linear or non-linear. If it's non-linear, use a handful of points. Okay? Use a handful of points. So we try negative 2, we get 4 back, right? What's another value inside here that we should use? Negative 1, okay? So I'm going to take negative 1, evaluate it at P, okay? So I do that. Obviously, if I take negative 1 and I plug it in here, negative 1 squared gives me the positive 1 here, right? Okay? Now, what's another good value to choose inside there? 0. So take 0, evaluate it as 0. Okay? So the x value is 0. Plug it in, I get 0 back, right? And I should keep doing that until I get enough of my curve in that interval. Okay? I would not say that's enough. I would need maybe 1, evaluate at P of 1. Gives me that. Okay? And the last one maybe I use is negative 2 or positive. I have to use the endpoints. I have to use these two. Okay? So 2, comma P of 2. Okay? So my hopes are you guys see that C and G, those two green points there, those are the locations when we evaluate it at negative 2 and positive 2, right? And if those are the only two that I get and I connect those, I just get a line, right? So I need to pay attention that it's non-linear, so I need multiple points. Now I always use convenient points. Squaring 1 and negative 1 and 0 is pretty convenient. But if you're a person that says, well, I don't care, I'll go ahead and evaluate this thing at, between -2 and 2, so, 1.33 or 2222 is there, so I'll evaluate that. Does that point still show up in relation to the other ones on that curve? Yeah, okay. So that's going to be part of the parabola that we're going to graph, okay? Now I get to this last rule. This last rule says x has got to be bigger than 2. Well, if x is bigger than 2, I still have to use 2 to get a starting point. If I put 2 in, what do I get back here? I get 4 back, okay? So I need to point 2, 4. And it puts it on top of that green one, right? But it's greater than, so what kind of point should it be? Should be open on top of that green one, right? Does that make sense? Okay. But I got an open dot on top of a closed dot, meaning that that point really is closed off, right? I guess so that should be a closed dot right there because there's an open on top of a closed, or a closed on top of an open, however you want to look at it. Okay. Now if I choose another point, now this here, is that linear or nonlinear? Guys, we should have 15 people saying linear right away, right? Okay, that's linear, okay? Take a value like 3, plug that in there, what do you get back? 3, okay? So 3 needs to be on my curve. Okay? Choose a number like maybe 5. Okay, so 5, 1. Okay, and you can choose as many points as you want because it's linear. 2 would have been enough. But now that if I graph that stuff, all the points that we chose are indeed on that curve, right? Okay? Is that curve a function? Yes. Okay? Because it's piecewise function. It has to be. Okay? But if we try the vertical line test, there will never be a situation where we get that vertical line test crossing my curve 2 times for the same x value. Alright, the only issues would be maybe there at A and G, but we know that one of those points at A was an open dot, one was a closed dot, so it's closed overall, and same thing happened at G. Is it okay? Alright, I'm going to write one more for us to work on here. Let's see. This is an example that shows you that the conditions, the domains, do not have to be the entire number line when you union them. Okay, we can skip over x values if we feel if that's necessary. Okay, or whatever we're trying to model in the real world maybe doesn't use those values. Maybe it's not necessary. So for instance, maybe this we're modeling something in the real world off of time, we would not incorporate negative numbers, right? Okay, but maybe in the first 10 minutes of observing something, it shows this pattern, and then in the second 10 minutes, so from 10 to 20 minutes, it shows a different pattern. So then we could maybe explain something with a piecewise that way. But this one here, first value I've got to choose would be what? 2. Okay? So we evaluate at 2, and this is the thing. If I evaluate at 2, let's see here, let's go. F of 2, see what it spits back to me. Undefined, right? Because there's no equality. So what we're really doing is evaluating at F of 1.9999, right? That gives me back 4. Is that the same thing that I get back? And now it's not really 4, it's like 3.999999999, right? Does that make sense? Okay. But is that close enough to 4? Yeah. So we're going to plot the point 2, 4, but what's it got to be? Got to be open. Okay. Now, this thing, is this linear or nonlinear? Nonlinear. So probably should use a couple other points, right? If I choose 1, what do I get back? 1, 1. If I choose 0, 0, 0, right? If I choose -1, I get 1 back. 2, I get 4 back, right? Oh, -2, I get 4 back. Okay. So I'm getting that aspect, right? Now, is that all I have, or does this thing keep going to the left? So when I graph this, this is going to be kind of my final point for that curve. But when I graph this thing should go, and it should keep going to the left, right? There should be an arrow maybe on that portion of the curve. So maybe I'll put 3.9 in here. I guess you won't even see 3.9 on my scale, so I'm not gonna put it in. All right, so that's fine for that. Now I get down here. What's the first value I gotta try here? 4. Okay. If I try 4, plug 4 in, I get
4.
yeah. Plug F of 4 in, it spits back 4 again. So 4 comma 4 needs to be a point. Is it open or closed?
Close.
It's closed. We've got equality. How many other points do I need here?
1.
I need one more. Okay. What would be a good x value to choose here?
5.
Huh?
5.
5? That's fine. What's a better one? Look at how these relate.
6.
6, right? 6 is going to give me back what?
0.
Yeah. Okay, so I can 0 comma f of 6. Plot that. What did I do? Oh, I did 6 comma f of 6. That gives me back that 0. Okay? So if I start plotting these things, reminding myself that this was one curve from that point right there, I get that. Right? If I hide all my points, except for A, and I probably want to keep what letter it was? E. Okay. So remind myself that those are open and closed respectively. Because if I don't put this on there, guys, if I don't do that, I interpret that as closed. Does that make sense? Okay. So I don't necessarily maybe need E because I do want that one to be closed, but I do need to have the open one. Okay. And that's the piecewise function. You see how we skip over the values from 2 to 4? And that's fine. Okay. Because through there, we pass the vertical line test. We do not intersect the curve more than one time, right? Okay, we intersect it 0 times, and that's fine. That still abides by the vertical line test. There is I opened it up yesterday. Some of you are saying it just opened this morning, maybe. There's a 2.2, you guys start on, it's not due till Tuesday, but you should have enough information to get through most of that.
It's nice in the dark out.
These are your kind of days.